Hi guys, Assalamu alaikum. This is Arif. In this video, I am going to show you how we can read from an input file using VHDL and system Verilog. And in order to do that, first I am going to show you how we can read the contents of an input file using a VHDL program and then using a system Verilog program. And for that, we are going to use the design of a ROM. So we are going to see how we can store a program which is written in the hex format in an input file, and using a ROM RTL program how we can read the contents of that input file. So in this VADL program, first we have given some libraries and we are going to use some functions from those libraries, and after that I have defined an entity whose name is program ROM, and this program ROM has actually two ports. One is PC, which is input port, and the other one is code, which is an output port. And PC we are going to use as an index to take out the values from our ROM array, which we are going to define later, and we are going to place those contents from the ROM array inside this code to display those onto the output. And after that we have defined an architecture, and in this architecture we have defined a variable ROM type which is of type, and it is actually an array which has depth of 256 and it has width of 16 bits. And after that we are going to define ROM variable as a signal using this type. So this is the type of our ROM variable, which is actually a signal. And in this ROM variable at specific indexes, like at 0 index, 1 index, we are going to store our program like this, which is going to be in terms of hex values. So this is actually we are giving the input to our program using this RTL code, these hex values. And later we are going to give actually these hex values from inside a input file to this program. And after that we have defined this code line inside this same begin block, and here we are using this PC as an index, and it is going to take out the values from this ROM, and we are going to display those hex values one by one into this output code. And this is our complete program of ROM. And now I am going to show you the test bench we are going to use for this program to simulate this. Here also we have first of all given some libraries, and after that we are giving the this program the name of Testbench. This is our entity, and after that this entity Testbench has the architecture which has the component which is the program ROM. And after that we are defining here two signals, PC and code, and these we are going to use inside this component which is program ROM, which we are calling from our main design code. And after that this process block, and in this we are going to first of all set the value of PC at 0, and after that inside this for loop we are going to increase the value of our PC by 1 using this code line. And here we are ending this for loop. Here this is wait statement, so that our process doesn't run forever. We are going to use this wait here, and this is our complete test bench. So let's try to run this program first and see how this program is working. Go to test bench, simulate, Run this program. So we can see our PC is going to take out those values and it is going to act as an index, and we can see those hex values in this window. So right now we had stored these hex values into our ROM array using this RTL code, and now I am going to show you how we can place these hex values inside an input file and how we can read these values from there. So let's comment out these lines and use this process block. So inside this process block, what we are doing here is, first of all, we are giving here the name of our input file, which is test.hex, and here we are using a keyword text. Here we are using a keyword file, open keyword, and then we are using here line keyword, right? And then we are using here end file keyword, read line keyword as well. So this end file keyword, read line keyword, this text keyword, file keyword, we are going to take these functions from this library. Use text.io.r. We are going to use this second library to take one function from this library as well, as that function is going to be this one, hread function. So here actually we are defining first of all a variable word which is a vector of length code, and here second variable read line which is of type line. So this line function we are going to use to read out the lines from our input file. Here we are opening that file, this file, using this code line. This is a file handle, and then using this hread function, whatever this read line function is giving us here, the lines of our input file, first of all we are going to store those inside this word, and then from this word we are going to put all these hex values using this index of the ROM this way: ROM 0, ROM 1, ROM 2. So from here we are going to get these hex values from the input file using this for loop and place those inside the ROM, and then we are going to say if the end of file comes, then exit this loop, and then end loop. So this is our complete program. Now I can show you the input file as well, which we are using. Go to this project folder, and here I have placed this file test.hex, where we have placed all our project files. This is the test bench. This is our design code. In this file we have written. So now let's compile this program. Save and compile this program. Simulate. Run this program, and we can see the same output. So now we have seen how we can use a VHDL code to read out the contents of an input file, which are going to be the hex values, and we are going to use those as input to our ROM program. And now let's flip over to our system Verilog program and see how we can do the same thing using system Verilog. So right now we are in our system Verilog project, and I can show you this is actually the design file where I have given this module name program ROM. It has this one input PC, one output code. Here we have defined those, and here we are defining the array which is ROM, and this array has width of 16 bits, and it has depth of 256. And after that we have defined here the initial block, and inside this block we are giving first of all these hex values, or storing hex values inside our ROM using this RTL code. And same way the test bench of this Verilog system Verilog code is like this test bench, and here we are giving the input as reg, and we are defining the output code as wire, and here we are calling that module program ROM like this. So after that our initial block begins, and here first of all we are setting the PC to 0, and after that we are increasing the PC by 1 here inside this for loop, and here we are giving the time span of 10 nanoseconds in between. So let's simulate this program as well. Go to wave, select the two ports, drag those to this window, wave, run the simulation, and we can see our output at PC 00 we have 000 hex values, at 01 PC we have this. So this is our output, and right now we are taking the values. So right now actually we are storing the hex values inside our ROM using this RTL code, system Verilog code, and now we are going to skip these code lines, and we are going to store those values inside an input file, and we are going to read these values, hex values, from that input file using this program ROM code. So let me first of all show you my input file. So if we go to this project folder, system Verilog project folder, where all the program files are saved, I have given here the same file test.hex, and this file I am going to read through this system Verilog code by this code line. So inside this begin block we are going to just place this one code line which is using a readmemh hex function, and this is our input file name. This is our ROM array where we are going to store those contents, this same ROM array. So in the case of system Verilog or Verilog, the process is very simple. We are not going to use any for loop or an if else block to extract the contents. just use this one function and that's it. That's where Verilog or system Verilog languages have the advantage. They look very simple. VIDL looks really complicated. Let's save this, compile this, simulate, run simulation, and we can see the same output. Let's close this window. So this is actually the way we can read the contents from an input file using VIDL and system Verilog codes and give those as input to our programs. And those contents here in this case were hex numbers. So I hope you guys have enjoyed this video. Have fun.